Let's do another log graphing. This is called graphing a logarithmic function basic. Okay, I'm gonna copy and then go over to ALEKS, find that topic in my ALEKS, open it, and then we'll go over it together. So graph the logarithmic function. They say plot 2 points on the graph of the function and also draw an asymptote. Now for asymptote, is always the default is x equals 0. Okay, default is x equals 0. Sometimes it gets shifted. Sometimes you have to plot x equals 2 or x equals 4, x equals 6 or x equals -2, it moves. How do we know it's gonna move? It depends on the transformation, okay? It depends on what is being added or what is being subtracted inside. So take a look. Open up the notepad real quick. If you have a function that says y equals log base 2 of x, the vertical asymptote is at x equals 0, okay? Let me give you something else. What if you have y equals log base 2 of x plus 5? If this is the case, you have a vertical asymptote at x equals -5. Why? This adding 5 inside will shift the graph 5 units to the left. I know, it's signs opposite, right? I want you to remember that. Next one, what if you have y equals log base 2 of x, not plus, how about I make it -7? Guess where the vertical asymptote is? At +7. It's at +7 because the graph got shifted 7 units to the right. But in our very function that ALEKS gave us, there's no vertical shift. I'm sorry, the horizontal shift. So the vertical asymptote is at x equals 0. I need to plot at least 2 points, they said. Ready? Let's plot 2 points. And plotting a point is nothing more than just plugging in some values. Okay, plugging in some values. So remember, argument can never be negative, and it cannot be 0 either. So what I will do is I will just plug in 1 and 2 into this function, log base 2 of x. Okay, what is log base 2 of 1? That is 0. Now why? Because 2 to the 0 power is equal to 1. That's why. But hey, if you didn't know how to evaluate that, I hope you have a scientific calculator, or what's it called, calculator, graphing calculator, to evaluate it yourself. But we did talk about how to rewrite this in exponential form so that we can have it in a format that we're more familiar with. You know 2 to the 0 power is 1, and this is why this is true. Next one. What is log base 2 of 2? Remember we talked about how if log base and the argument is exactly the same, then the log expression will turn into 1. Why? Because 2 to the first power is equal to 2. Because of that, this log expression is equal to 1. Now, that means I'm going to plot 1, 0 and 2, 1 to graph this function. Okay? 1, 0. 1, 0 and 2, 1. That's enough. And if I go ahead and click on this function, the graphing function, and click on check, yay, I got it right. Let me do one more with you, okay? So next one. Oh, what's this? It's an ugly looking function, this is. Okay, so this is g of x equals 2 times log base 1/3 of x, okay? Well, good news is it's not shifted to the right or left at all. Okay, you see that this x inside this parenthesis for the argument, it doesn't have any +5 or -3 or anything like that going on. So the asymptote is still at x equals 0. Okay, the asymptote is still at x equals 0. Now, how do you know asymptote is somewhere other than x equals 0? If this x that I, highlighted in red, if it was like x plus 5 or x minus 3, then it has a vertical asymptote other than x equals 0. But because it was just x for the argument, it's just going to be x equals 0 for the vertical asymptote. Now, I know it's a little yucky, but we have to find two values, right? So x and y. I'll plug in 1. You know what? 1 may not be such a pretty number. Hey, maybe not, maybe not. Let's go with one. Let's go with one. That's going to be 2 times log base 1/3 of 1. It's too early in the morning. It's 7:30 in the morning. I may just try to type this into my calculator then. Okay? So I'll go ahead and do 2 times math log base. Log base is 1/3. And I'm going to plug in 1 in here. If I hit enter, that is 0. That is just 0. Okay. Next one. What if I plug in 1/3 in here? Oh, look at that. Why am I doing that? Because if I plug in 1/3, you notice how this log base of 1/3 and this argument of 1/3, they are exactly the same thing. So this is going to give us 2 times 1 because this is just 1, right? And 2 times 1 is 2. So I can plot a point at 1/3, comma 2. So I have 2 points to plot, 1, 0, and 1/3 and 2. 1, 0, and 1/3 at 2. And then I'll go ahead and click on this graph. I'm a little concerned. Well, oh, no, this is fine. I thought this was going, it's like flipped upside down, but it's going down. It's a decreasing function because look at the base. The base is 1/3. Okay. Click on check. We did a good job. So that's how you can do these graphing logarithmic functions. They said basic, but this one didn't really look too basic to me. But the trick is we just need to evaluate a couple log expressions to plot some points and remembering to graph those vertical asymptotes. So I hope this was helpful. Find me other topics if you want me to go over anything else. But if you want to talk a little more about this, maybe we can set up an office hour, like Zoom meeting. Okay? All right, I'll go ahead and process this and send it to you now.